work at a studio named nøcomputer, and for a studio that is named nøcomputer, we do an awful lot of things with computers. So today I'll take you through our process and how we got started and how we built our installations and give you a peek at how we will build installations in the future. So a social worker, an architect, and a graphic designer walk into a bar. And that's basically our background. So we are not trained in computer science or anything. We could have easily been a punk rocker, a rapper, and an electronic musician walk into a bar. Because we all kind of tried to get into music and have a career, but like only the punk rocker succeeded because he has the good hair and the guitar, of course. Beats weren't really kind of that important in Belgium at that time. So I dug into my archive, and this is like the earliest picture I could find of the three of us. This is during a workshop at IMAL in Brussels. In the back you see Arturo Castro, who's the lead developer of Open Framework. So he was teaching a workshop on doing open frameworks running on iOS devices. So when we got started, computers kind of looked like these beige machines. So on the left is the Tandy, that's Wim's computer. We still have that lying around the studio. Like I was working mainly on a Commodore 386 with a monochrome screen. So things looked kind of different at that point, because there was like only one layer you could draw on. So I had this software called Draw Perfect. And this was the one I've used to kind of take, just as an introduction to vector graphics. It's a bit like a really primitive version of Illustrator. And at that time, in the early 90s, I also programmed my first basic programs. And, well, couldn't really call it programming. It was more like typing things from a book and seeing what happened, not understanding at all what was going on inside the machine. And so then we moved on to software that had layers, like Photoshop 3. And one of the most amazing pieces of software ever made in the 90s was like Kai's Power Tools. Yeah, oh, some people who used it. So Kai had some really funky interfaces and really weird filters, and you could do really creative things with that. And then we kind of moved on to software with layers, but also had a timeline. Like when you see the first versions of After Effects, you just had basically a Photoshop, but you could animate all the effects parameters. But it was kind of slow, because if you did really crazy things, your computer could render like 3 days for a video of 4 seconds or so. Then came the really fun things, like late 90s, Flash 3 and Macromedia Director. And these also had a timeline and layers, but you could also kind of use basic code to jump to certain frames in the timeline. While Flash was like more a web-based platform, it was like Director, you had a bit more options because you had access to the file system and you could play video and do some early 3D experiments. These are some slides from one of my first installations from like about 15 years ago. So I was really into glitch art and playing around with a lot of photos, and these were just rotating around the screen, moving, applied filters and blend modes to get some kind of interesting interactive results. And then there was the Webcam Extra, developed by JT Nimoy, and that kind of introduced me to computer vision in creating applications within Director. So there's go to the frame. That was actually a piece of code in Director, so you would use Lingo, and that's a language which is quite close to English to program, so you don't need curly braces or anything. But it's a really weird and exotic language. And so after that, I moved to processing and Arduino and open framework, starting with the early beta and alpha versions. And so this is what our work, well, in the past 15 years kind of looked like. These were little experiments we all did. This is some work from me and from Gwen. So we really did a lot of generative art and then rendered videos and pictures and kind of uploaded them to all the platforms. And then we went to some simple, well, interactive installations. So basically, you take the input from a camera, you run it through an Open Frameworks app, and you create some visual output. So when going through the archives, I noticed a lot of things that we had in common, and this was like just putting your face in front of a camera and just pull it into weird angles to create 3D outputs. And then another interesting thing was like using lights and reflective materials and the webcam in your hand as a tool to create as sort of first visual or VJ installations. Then in 2010, there was the Kinect. And this kind of changed a lot of things for us because you suddenly had access to point clowns and skeletons, and you could do really interesting things with that. Short look at my dance moves, so this was a really fun project to do. Really early experiments, but and this was also fun thing like controlling DMX lights with your hands by just moving them in front of the camera. And from that, we started to do a bit more advanced computer vision things. Like here, we tried to create the poor man's Kinect to just see if we could do skeleton tracking with just regular webcams and OpenCV. Then fast forward to where we are now. So late last year, we did a project for the Grammys. It's called Play the City. It's to celebrate the Grammys returning to New York. We made an augmented reality installation in a driving car. So I'm going to show the case video and then explain a bit more on how we kind of pulled everything off.
Colleen?
Yeah.
Right on. Hi, Mina?
Hi, yeah.
4th and 6th here?
Yep.
That's us.
All right.
What is this?
You see that? H part?
What the hell is going on?
Those are people. Oh my gosh.
Right?
It does music notes when there's people. Oh no, it's a fire hydrant!
Wow.
It was making music as we drove along. I've never seen anything like that.
I've never seen anything like this.
How does that happen?
Okay, so we start with rigging a camera on the car. We have 2 computers in the car. One computer is responsible for taking in the video. It will know the difference between cars and people, fire hydrants, sends all of this data to another computer. that is responsible for generating the music and creating the visuals as an augmented layer on top of the video feed.
Dog made a different sound for sure.
It's like really cool to see people are making music and they don't even know it.
I should have told you to take me to Staten Island.
It's like the mixtape of New York. It was like beautiful.
Okay, so when we kind of start our installations, they look somewhat like this on the whiteboard. When we present them, they look like this. So I'm really good at stealing art from openclipart.org and kind of make illustrations with it. So basically, we have the GoPro there. And we feed it into the Blackmagic Design capture card and into the first computer. And that computer serves as a video server application and also does the computer vision, so the holo detector. And then the raw video stream is also fed to the second computer, where we overlay the data. So each person or car or fire hydrant gets its own shape. Then we overlay that on top of the video feed. And all of these objects also get converted to MIDI notes, so we can use it to generate the music on the fly. So everybody taking a ride in the car gets a really different experience, because the soundtrack will always be different. And then there's a battery to power everything. So when we were testing the installation, we drove around New York in a car that looked like this. So you have battery and screen, lots of duct tape. One of the, well, bad things about it is like the battery can only last for like 30 minutes. In this case, so you have to drive, capture some footage so you can use it for testing later. Then sometimes our offices look like this. This is in a garage in New York where we were working just with the people who are building the installation into the car, doing some development there. Then in the final installation, everything is neatly put into the trunk of the car. And then on shooting day, this happens. We were stuck in New York, and the shoot, well, didn't go through, so we had to postpone everything for a few days until we got the permits to. It was really stressful because we didn't know, there was also a chance that the work we had been doing for 4 weeks would have ended up, well, in the trash can. So while developing these new and more large-scale applications, we kind of noticed that we needed to change our workflow a bit. So all of our installations kind of live in this space. You have on the other hand parametric and on the other hand generative, and they can be interactive or static. And it's usually a mix of these 4 ingredients. So the output could, for instance, be a generative print or something really interactive where you stand with your whole body in front of a Kinect. And while developing, we noticed that, well, we're using a lot of add-ons to create open frameworks applications, for instance. But the problem is all our installations don't run on a single computer anymore. So we can't just include everything into a single app and make it run. And the add-ons are great, but well, adding them to projects, and you have to kind of write a lot of code over and over again. So right now we are kind of moving to building really small applications that do a single thing, and they are networked, so they can communicate with each other, and they are easily distributable on multiple machines, so you can create bigger and more powerful installations. So once you have a lot of these apps, they kind of reduce development time a bit, but we don't take anything away from the budget, so we have more time for like the creative output, for the visuals and the music. And some apps well, won't be able to split tasks into something general, so we need to do custom development as well in each installation. And so for building these apps, we really want to use the best language possible or the best platform possible. So if you use Kinect, for instance, the best platform will be Windows with the Microsoft Kinect SDK and not running it on a Mac, for instance. And for machine learning, it's best to do everything in Python rather than JavaScript. So when we take a look at the architecture of big installation, you usually have a bunch of inputs like depth sensors, electronics or cameras, and then we have data processing. Then we have control panel who kind of orchestrates everything, and then the custom outputs layer. And some of the things are reusable in, well, not in a lot of cases, but for simple tasks they are. I'm going to show this in a minute. But in order to kind of like build a really modular installation, you need to have some rules. So rule 1 is each app should be able to, you should be able to configure it, so with an XML or JSON file. So for instance, input can be like a distance sensor connected to pin A4 on the Arduino, and it generates values between 0 and 1024. When you use Fermata on the Arduino, you can easily reprogram it on the fly from an OpenFrameworks app. And then you can decide what to do with the inputs. So in this case, we're taking the inputs from the distance sensor, sending it over OSC, and also convert it to a range between 0 and 100%. So each app in the whole system should also be able to receive OSC commands from the control panel, so you can trigger actions. So for instance, an app can receive a command to record videos, to stop recording, and then send its data to the next app in line. And you also need to use standard protocols for these communications between apps. So we used quite a bit of custom TCP messages in the past, but that's kind of like not sustainable, so we moved to 0MQ for communication between apps in different languages, OSC for commands, and then you have MIDI to control hardware synthesizers or Ableton. Then Spout can be used for sending video between apps on the same machine, and NDI if you need to send video to other computers on the network. And we also need to use like standard data formats for these communications. So if you have some more complex multi-part data, use a JSON object. If you just have single data points, you can just use floats or strings or ints. So if you take a look at inputs, you could, for instance, build a depth sensor app where you can plug in any type of sensor, configure it, and then just route the outputs or the different layers of outputs to other applications in the system. So for the Kinect, for instance, you could say, I need a point cloud and the RGB video and the depth video for calibration of the system if you have multiple Kinect. And then once the installation is running, you can kind of just use the skeleton data and turn the rest off so you don't overflow the network with unnecessary information. So Kinect is like our favorite sensor. We've been using it since 2010. But Microsoft has kind of discontinued it a bit. And we're getting into trouble. Like maybe in 5 years, we won't be able to use it anymore. So we are taking a look at some other sensors as well. So there's the Stereolabs Z. And this one is a great one. It has a much farther range. And it can also be used outside, since it doesn't work with infrared light. Then there's the Incel RealSense. This is a really interesting device, since it's quite small and it's easily to build into installation, so to hide it. Where the Kinect is quite bulky and it's fairly difficult to hide it. Then there's a camera app. This one we've kind of built because we need to send video from the same webcam to different processes. So you need, for instance, send it to the YOLO detector, send it to the video screens as output, and maybe even some more processes. So you can use like the Logitech webcam or a GoPro or professional camera connected through the Blackmagic shuttle. So these are some devices you probably know, like a single webcam and a GoPro. And the intensity shuttle is a really good thing since you can connect a lot of different video formats like S-video and composite. And then for custom electronics, that's a tad bit of a difficult one to reuse at times. But there's a lot of things you can do. Like if you run Fermat on the Arduino, you can generally get the data out in raw or normalized form if you need it. So everybody knows the Arduino probably. And this is another device we've used in the past, the Yoctopus. They make these really specialized devices. They're more industrial grade, have a really great API to work with. And they do just specific things. For this is, for instance, one that does RS485 communication to control flip dots, for instance. And then there's the Axolotti, one of my favorite devices. So this can take sensor input and generate MIDI from it or audio. And you can, it's a great thing to build like custom synthesizers with. And then the iPack is used in arcade cabinets, so you can connect arcade buttons, joysticks, and use those as inputs. And you plug it in the computer, and it just reacts as a regular computer keyboard. Then there's the data processing part. So for a lot of things, like for computer vision, there's a certain kind of tasks that we need to do a lot, and those can be combined into a single app as well. And you can toggle things on and off when you need them. So for instance, face detection, smile detection, colors or shapes, lines, those are things you can easily generalize to get data out of it. The YOLO detector, for instance, as well. And then there's things like regular machine learning, like with TensorFlow in Python. That's a bit harder to reuse at times because they are really built to do specific things like pattern recognition in fashion, but I'll show you that one later. So like this is the YOLO detector we've been using. So each of the menus can be, well, changed with a few parameters, and then the detected data can be sent to the next application in line. Network storage is also an important one. So we have an app that can record video. You can send it commands to kind of save still images or small video files. And when it's done recording, it sends the name of the video file to the next app who can start, well, display it or do machine learning on it. And then there's the control app. So most installations kind of run on their own, but sometimes you kind of need to, well, be able to push a button to stop something, just in case something goes wrong. And the control panel sends commands to the data hub, and this one routes everything throughout the whole system. It also routes the data from one app to the other, or to the outputs, and it's also able to do data conversion. But this is one, well, we still have to think a lot about to build, because that's a fairly difficult one to do in a general way. So this is a picture of an installation we did in New York lately to detect fashion. So you see a lot of Open Frameworks apps running, and then on the left here you see one of the Node.js panels here we built to send some other commands to the system. And then there's different types of outputs on the installation, and this is usually very custom built. So we kind of focus on doing the rest in a kind of general way, so we can spend more time on all of this. So for instance, there's a web output. So we did an installation where we needed to control more than 1,000 smartphones at a conference. And I noticed that Chrome can only render like 1,000 of them. It just stops after that. So we did a small test video here where we kind of split more than 1,000 iframes over a few computers just to test if our concept would work. Then on the event, people were just holding their smartphones up, and we played the video, and each smartphone is a pixel in the screen. And then there's like a comedian and a robot on stage for some reason, and some fireworks as well. So there's also a thing where you need to control a lot of computers. So for instance, synchronized video playback on a big installation. For this case, we kind of developed a system where we had 50 Raspberry Pis connected to a big router, and then each one had its own screen, and we had one laptop that could control everything else. And this was built into this installation here at Us by Night in 2017. There's also audio output. So in the installation we've shown, we've used Ableton most, but you can also use the Axolotl, for instance, when you want to, well, generate audio on the fly. So in this case, each track has its own MIDI channel, the data comes in, and that's the way we kind of defined of how what object would make what sound in the installation. Then it comes to visual output. So we worked a lot with open frameworks in the past to do the visuals, and last year we kind of switched to Unity because we kind of felt we needed to kind of upgrade our visuals and really make them a bit more polished, and that's quite a bit easier in Unity. You need to put in less effort to build an installation. So I'm going to show you a case video of an installation we've built with Dog Studio, and Matt Delorier and David Leonards also helped us during this one. So this installation runs on 2 Kinects and 14 screens, and that was a tough one to build because we just had switched to Unity, and we also needed to port our Kinect scanning app to Unity in this case because there was some trouble in using open frameworks to kind of get the data in there with the add-on we are using. Then there's also custom electronics output. So in this case, I'm showing you this project for Adidas we've built. And these are flip dots, and you can control each of these dots. One of the problems you kind of can get into is that it's quite of a bottleneck because it uses a really old serial protocol. And the more panels you kind of add to the system, the slower it will be. So like if you see like this is 5 panels together, and this can still run at an acceptable frame rate to show small animations. But when you go bigger, well, you need to kind of design in another way for it. And so as promised, I'm going to take you back to the, well, show you the back of our installations. So next project is something we have never shown before. This is the first time. So in September, we did a project for New Balance where we used machine learning to kind of detect the people who are standing out of the crowd. So during Fashion Week, there's a lot of people wearing just about anything. And we took a lot of footage and analyzed it to see what the general public was wearing. And then did pattern detection and color detection to kind of pick the person out that was standing out of the crowd. And then he was handed a pair of New Balance shoes.
Hi, my name is Alyssa. I'm a fashion editor out here with New Balance to spot exceptional outfits on the street. And the way we're doing that actually is with artificial intelligence. How would you describe your personal style?
Like if people are going right, I go left.
I like to be loud.
I dress more so with my emotion.
I just have to push myself to wear something that I'm a little less comfortable in, but I know that looks good.
I treat fashion like, you know, I treat music. It's just kind of like improvisation.
Anything, everything inspires me.
No, I don't follow that.
So that was fun. So the installation looks a little bit. You see a black dot there on the screen. There's a camera. Then there's the 3 screens built in to the windows of the building. But this is what the audience gets to see. So when you get to the back of the installation, something more like this. So you have a real technical setup, a lot of computers, people running around. It's a really busy set to be on. This is also funny. When you see somebody dancing to your installation, this is what you know where, well, OK, you've done something right. This looks like really pretty. There's some screens on the wall, nicely framed. Then when you can look to the backside, it looks like this. So it's just a bunch of computers taped to a wall. I guess that's kind of it for my talk. No computers. Thanks.